Hi guys, so today we'll be solving this problem called construct binary tree from preorder and inorder traversal. Let's read it. Given two integer array preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree. Construct and return the binary tree. Okay, so we've been given the inorder and preorder traversal of a tree, and we need to, you know, make a tree from those two pre-order and in-order traversals. So I'll be explaining it with an example. Let's understand it. So first of all, we've been given an example of pre-order traversal array, which is 3, 9, 20, 15, and 7. Okay. Uh, I think this wouldn't be visible to you, so let me write it here. Pre is equal to 3, 9, 20, 15, and 7, and in is equal to 9, 13, 15, 9, 3. Okay, 9, 3, 15, 20, and 7. Okay, so let's understand this. First of all, let me just write down the indexes. So we've been given two array, and every time we know we've been asked a pre-order traversal, we know we're going to traverse the tree by going to its middle, then going to its left, and going to its right. All right. And every time we are asked in order traversal, we are going to go to its left, then middle, then right. Okay. These are the order in which we do traversal. Okay. Now, in this one, we can see that pre would always be in the fashion middle, left, and right. All right. So from this, I can understand that in this array, the zeroth index would be the middle element. So zeroth index is the middle element. That means it is the root. It is the root of the tree. All right. So making it as the root of the tree. All right. And now what we do is that in order array, we know that it's in the left, middle, and right fashion. All right. So in this, if we search 3, okay, 3 is at the first index. All right. Now if we search 3, we know that everything on the left of 3, all right, if suppose I say 3 is the middle element, so everything on the left of 3 would be in the left subtree. All right. And everything on the right of 3 would be in the right subtree. All right. So 3 would be having 9 on its left, and all these elements on its right. Okay. So we have come this far, all right, to construct the tree. So now we've considered the first zeroth index. Now we go to the second index. Second index is 9, but 9 is already traversed. So we see its index in order, all right, and we see it's on zeroth index. So we know that everything on the left of it would be to the left of the the node, and everything on the right would be in the right of the node. So 9 will be having to its left as null pointer, and to the right it would be having all these elements. Okay. Now we go to the second element, which is 20. Now we find 20 in order. We know it's at third next, so everything to the left would be to the left of the 20, and to the right would be the to the right of the 20. So 3 will be having 20 to its right, because we know that it's to the right. So 20 would be having left as 15, which is here, and right as 7. Okay. So this is how we are going to construct the tree, by just taking one element from the pre-order array and finding it in the in-order array, and finding its index and making sure that everything on the left of it would be in the left subtree and everything on the right of it would be in the right subtree. That's what we need to do. So for this, the condition that we need to follow is that we'll be making a node. All right, let me call it root. Okay, so everything on the root's left would be everything from in order start index to the index. Say suppose I found this at I found it at ith index. All right, so everything would be in the left of the root. In the left of the root would be from in order, which is the start index, till the in order I minus 1th index. All right, because we know that everything in the array, if we say that let me just if we say that we have an array, we found the ith here, so we know that everything towards the left would be in the left and towards the right of it would be in the right subtree. So in the roots left, everything starting from the start index to the I minus 1th index, which is here, from the start to I minus 1th index will be in the left subtree, and everything on the right would be in order I plus 1 to in order uh, end. All right, so that would be the order in which we need to uh, construct the tree. All right, so now I'll be coding this, and exactly what I wrote here, that's what we'll be doing in the code. Let's do it. So first of all, we have been given a function which is build tree. We have two elements, right? So, two arrays, right, which is in order and pre-order. So let me just take out the size of one of them. So the size would be the same for both of them, so you can take any of it. Then you return one more function, which is build tree construct. Okay, build tree construct. So in this you'll be passing pre-order, you'll be passing in order, you'll be passing the start index, which is 0, right? The start index of in order would be 0 till n minus 1, which is the end index. Now coming to build tree construct, we have vector int pre-order, we have vector int in order, and then we have 0th start index, then we have the end index. All right, so coming here, as we said, the first step that we'll be doing is that we'll be finding the pre-order element, which is the first element. So for that, to keep a counter for the pre-order index, I'll be making a pre-index here globally, so that we can keep a count as in when we go towards the end of the pre-order array. So first we'll be creating a node. Root is equal to new tree node, and we'll be having a pre-order of pre-index. Okay, so we'll be creating, since pre-index is basically the counter, which is the index of every element that we'll be going through in the pre-order array. So first of all, we take the first element. Pre-index is 0, therefore we take the first element from pre-order array and we put it in, make it the root. All right, that's what we had discussed, right? So also we'll be doing pre-index plus plus, so that we increase the counter for the next element that we need to encounter. Now what I'll be doing is that I'll be finding the root node in the in order array. So I is less than n, I plus plus, and I'll be finding if root val. All right, root val is equal to in order I. At that time, I'll be creating one more variable for Inorder index. So let me initialize it to 0. So whenever we found the element in the Inorder array, at that time we'll be storing the Inorder index, and then we'll be breaking from the loop, because that's what we need right here. And then coming out of the loop, we have to do the same two functions, which is what will be in the left of this tree would be that build tree construct. We'll be passing preorder, inorder, order, and start would be as it is for the left of it, and end would be in I in index -1, and roots right would be equal to build tree preorder, comma in order, and everything to its we will be starting from in index +1. So everything on the right of the index would be in the right subtree. So in index +1 to the end is as it is. All right, and then simply from here we'll be returning the root. Okay, now we need to keep a check that the base condition for this recursion to n would be that if start is greater than n, all right, at that time we return null pointer. So we know that the start can't be greater than n, because that would violate the condition that it will go out of the bound, which is out of the index, right? So that's why we need to make sure that the start doesn't become greater than the n. All right, so yeah, that's it, what we have to do. Let's run the code to see if everything is working fine. Yeah, that is accepted. So I hope you guys understood the problem. Do solve it, and do like the video and share the video and subscribe to the channel, and thank you.